Video number 20, probability and significance. Probability is a numerical measure of the likelihood of an event occurring. So if an event is certain to occur, it has a probability of 1, and if an event is certain not to happen, then it has a probability of 0. And that can vary between 0 and 1 for any particular event. So we use probability in psychology in order to test hypotheses. So let's imagine a hypothesis. Let's imagine that I think that psychology students are more punctual than sociology students. So first of all, let me write down my two hypotheses. The alternative hypothesis is that psychology students have a better recorded punctuality than sociology students, and by recorded punctuality I mean what I can read off Sims. And my null hypothesis is that any differences in the recorded punctuality between psychology students and sociology students is due to chance. Okay, so supposing I run a little experiment. Supposing that I've got a psychology class in B5 and a sociology class in B6, period 1 on Monday morning, and I measure their punctuality for 3 weeks running and I work out an average. And it turns out that on average, 20 out of 24 psychology students are punctual for that lesson, and 15 out of 19 sociology students are punctual. And that gives me the percentages of 83% and 79%. Well, it certainly looks, according to that data, as though psychology students are more punctual, doesn't it? But the question is that true of just this sample, or is it actually true of all of the psychology and sociology students in school? In other words, can I generalise from my sample to the population or not? What are the chances that the obtained results reflect a true difference in the wider population? And what are the chances, what is the probability that the results that I've obtained are just down to random variation? Well, a statistical test allows me to measure the probability of those things. And thus, it helps us to choose between the alternative hypothesis and the null hypothesis. A statistical test starts from the assumption that the null hypothesis is true, and then allows us to calculate a value of p. P is the probability that the results that we've obtained are just due to chance. In other words, in our experiment, assume that psychology students and sociology students, there's no difference in their punctuality. Well, what are the chances of getting the observed difference in their punctuality? We set an arbitrary value, a significance level for p, and we say that if the calculated value of p is less than the significance level, then we reject the null hypothesis and accept the alternative hypothesis. So, in our experiment of psychology and sociology students, the statistical test assumes that there is no difference between the punctuality of sociology students and psychology students. And then we look at the observed result that we've got, which was that 83% of the psychologists were punctual as opposed to 79% of the sociologists. And the statistical test says, what are the chances that that could happen just by chance? It just so happened that on this particular day that the results turned out that way. And it allows us to calculate a percentage probability that those results are just due to chance. If we can then say that that percentage probability, p, is less than 5%, then that gives us a reason to reject the null hypothesis. The null hypothesis being that there are no differences between the two different types of student, and that any differences between them are just due to chance. If P comes in at less than the significance level, then we reject the null hypothesis. If, on the other hand, the statistical test tells us that the chances of getting the results that we've got are actually quite high and larger than 5%, then we would accept the null hypothesis. And we would say, okay, so there was a difference between the psychology students and the sociology students' punctuality, but we think it was probably just chance. And we think that in actual fact, there's no real difference in the punctuality of psychology students and sociology students, and the fact that the psychologists were more punctual on these 3 days, well, that's just a random throw of the dice. Because the chances of that happening are more than 5%. So we're not going to reject the null hypothesis on the basis of the outcome of this experiment. So what a statistical test does in psychology is allow us to place a numerical value on our degree of certainty and uncertainty on the null hypothesis. And we can never be quite sure that the null is true or the null is false. Are psychology students more punctual than sociology students? Well, these ones on our Monday morning certainly were more punctual than the sociology students. Are psychology students generally more punctual than sociology students? Well, our statistical test allows us to place a numerical value on our degree of certainty in that statement. All right, in a minute we're going to look at the difference between type 1 and type 2 errors, but first it is time for this week's random psychology fact.
This week's random psychology fact is that in 2008, 270 psychologists replicated 100 top psychological studies that had been published, and they found that only half of the studies that were replicated got the same results.
Well, that was this week's random psychology fact. Okay, type 1 and type 2 errors. A type 1 error is a false positive, and a type 2 error is a false negative. So let's illustrate what we mean by that in terms of the psychology-sociology lateness experiment. Let's supposing that there's actually no real difference between psychology students and sociology students in terms of their punctuality. They're just the same. But on the particular 3 Mondays that I measured it, the sociologist did just happen to be more punctual than the sociology students. And so from the outcome of that experiment, I draw the conclusion, a false conclusion, that psychology students are more punctual than sociology students. They're not. It just so happened that on the days that I did the experiment, they were more punctual, and then I generalised that result to the wider population. But in fact, I'm making a mistake, because psychology and sociology students are not more punctual one than the other. That would be a type 1 error, a false positive. The experiment has given a positive result, and we have rejected the null hypothesis, but we've done so falsely, and it's a mistake, because the null hypothesis is actually true. Type 1 error is rejecting the null hypothesis when in actual fact the null hypothesis is true. A type 2 error is the exact opposite of that. It is accepting the null hypothesis when in actual fact it's false. It's a false negative. So supposing, for example, I did the maths on my statistics in my psychology-sociology experiment, and I said, well, the observed difference between the psychology students and the sociology students didn't achieve significance. P was above 5%, And that means that I think that the observed differences between the psychology and sociology students are down to chance. Therefore, I'm going to accept my null hypothesis. I'm going to accept that there is no difference, no underlying difference between psychology and sociology students in terms of their punctuality, and that the differences that I observed on this particular day were just down to chance. But in actual fact, psychology students are more punctual than sociology students. That would be a type 2 error, a false negative, when my statistics tell me to accept the null, but the null is actually false, and that there is a true difference between the two groups. That's a type 2 error. Type 1, false positive, type 2, false negative. And I can best illustrate, I think, the difference between type 1 and a type 2 error in terms of a little contingency table. Okay, this is a 2 by 2 contingency table, and it compares the truth to what the test is telling us. So along the top, we've got two conditions. Either the alternative hypothesis is true and the null is false, or the null hypothesis is true and the alternative hypothesis is false. And down the left-hand side, we're going to put what the test is telling us. Either the test tells us to reject the null hypothesis, or it tells us to accept the null hypothesis. Now, obviously, what we want is a true result, either a true positive or a true negative, and that is those two quadrants of the table on the top left and the bottom right. The top left one is when we reject the null hypothesis, and in actual fact, the null hypothesis is incorrect and the alternative hypothesis is correct. So, in our psychology and sociology experiment, this would be rejecting the null hypothesis, accepting that psychology students are more punctual than sociology students, and in actual fact, psychology students are more punctual than sociology students. Another desirable outcome is the bottom right cell in the contingency table, where we accept the null hypothesis and in actual fact the null hypothesis is correct. So this would be when our statistics fail to achieve significance. It might be that the psychologists were more punctual than the sociologists, but not so much so that we think that the results are completely due to chance. So we accept the null hypothesis, and in actual fact there is no real difference between the psychology and the sociology students, and the null hypothesis is correct because the observed differences between them were just random variation. So those are the two desirable outcomes, the true positive and the true negative outcomes. The ones that we're worried about are the two different types of error, the false positive and the false negative, the type 1 and the type 2. So the type 1 error, the false positive, falls in the top right quadrant of the table. And this is when we have a false positive result. And the test is telling us to reject the null hypothesis, and we do reject the null hypothesis, but in actual fact, the results were due to chance. And there is no true difference between the two conditions. Type 1, false positive error. And the bottom left quadrant of the table is a type 2 error, a false negative. And this is when we are accepting the null hypothesis. We think that there is no true difference between the two conditions, but in actual fact, the test did not detect the true, actual, underlying difference between the two variables, and we have a false negative. We accept the null hypothesis and we do so incorrectly. Now, we don't want either a type 1 or a type 2 error. We don't want any kind of error at all. But we might get one. And that's the nature of statistical testing. There's always going to be a degree of uncertainty. What we can do, though, is balance the difference between the probability of a type 1 and a type 2 error. And that's why we choose 5% as the normal level of significance in statistical testing, is because it balances the probability of a type 1 error and a type 2 error. If we set P too low, in other words, if we make our test too stringent and we make it too difficult to achieve significance, then we're going to get false negative errors. We're going to get type 2 errors, and we're going to overlook true effects just because they didn't achieve significance in this particular experiment or statistical test. Conversely, if we set P too high and we make the test too lenient, then we're going to get type 1 errors, false positive errors. We're going to detect true differences between the two conditions or the two variables, where in actual fact the results just are due to chance and there's no true difference between the two variables, and that would be a false positive error, detecting a difference where in fact there is none. 5% is the level of significance which is thought to keep a pretty decent balance between a type 1, but between the likelihood of a type 1 and a type 2 error. Sometimes, in psychology, we might use a more stringent type of statistical test. We might use the 1% level, or even like the 0.005% level, or even more stringent. And we would do this if we wanted to be more certain that the effect is real. In other words, if we wanted to minimize the likelihood of a type 1 error. And we might do this, for example, if we were testing drugs for treatment for mental illness, which were going to be issued to people, or if we were replicating research which had already been done by another researcher.
This week's run.
Okay, in this video, we've looked at P and probability and type 1 and type 2 errors.
This week's random.